Hello everyone, welcome back to the channel. Today we are going to explore an exciting topic in modern transportation technology known as the Vehicular IoT. It is also known as the Internet of Vehicles. So let us begin with the introduction. The Vehicular IoT, it connects the vehicles to the internet and it allows them to communicate with other vehicles, roadside units and the cloud servers. This communication helps create a smart and efficient transportation system. Now here you can see there is a vehicle which is shown here. It is connected to the internet through a communication network and the cloud servers. Communication network and the cloud servers, and this connection enables the vehicle to send and receive the information in real time. As a result, the vehicles can share important data with other vehicles and the transportation systems. Now here you can see some challenges which occurs due to the increasing vehicles, or you can say some major problems which are caused by the increasing number of vehicles on the road. The problems include road accidents, then traffic congestions, parking issues, vehicle theft, and the poor traffic management. And these challenges affect both the drivers and the transportation authorities and make road travel less efficient and less safe. Here you can see how the Vehicular IoT helps to solve these problems. The vehicles here continuously collect, share and process the information through the IoT technology, and different sensors and communication devices are installed in the vehicles, monitor road conditions, traffic situations and vehicle performance. Now here you can also see some important functions of the Vehicular IoT. That is, it can detect the road conditions, then which helps the drivers avoid damage or the to avoid the damaged or the unsafe roads, and they can monitor their own health and such as engine condition, fuel level and the battery status. Vehicles can also share the traffic information with nearby vehicles in order to reduce the congestion. In addition to this, the system can warn the drivers about the accidents or dangerous situations ahead. And another useful feature is the remote tracking. So here the remote tracking, which allows the vehicle owners to monitor their vehicles from anywhere in the world. Now the message here at the bottom, it summarizes the purpose of the Vehicular IoT, that is by connecting vehicles, communication networks and cloud system, Vehicular IoT makes the transportation smarter, safer and more efficient for everyone, and it improves the road safety, reduces the traffic problems, support better vehicle management and enhances the overall transportation experience for everyone. Now we will look at the architecture of the Vehicular IoT. So here it is a three-layer architecture of Vehicular IoT which helps create a smart and connected transportation system. You have three layers here. First is the device layer, then fog layer and the cloud layer. The device layer is the bottom layer and it includes the vehicle's roadside unit, that is the RSU, cameras, sensors, GPS and other devices. And this layer, it collects the data from the vehicle and its surroundings, performs sensing, shares the information and triggers events such as accident alerts. Then comes the fog layer, which is the second layer, or you can say it is the middle layer. It consists of the fog nodes located close to the vehicles. This layer performs the real-time analytics, short-term storage and quick decision making. Now because processing happens near the devices, response time is very fast, which helps prevent accidents and improve the traffic management. And then comes the third layer, that is the cloud layer. It is also the top layer. It contains the powerful cloud servers that perform the high-end processing, big data analytics and long-term storage and decision making. The cloud analyzes the large amount of data collected from many devices, many vehicles, and together these three layers work efficiently to provide safer transportation, faster responses, better traffic management and smarter vehicle communication. Now we will look at these layers in detail one by one. First is the device layer. Here this is the bottom most layer of the Vehicular IoT architecture, And this layer acts as a foundation of the entire system because it is responsible for collecting the data from the vehicle and its surrounding environment. Now you can see here the main components of the layer. These include the vehicles, then sensors, cameras, GPS, and the roadside units, that is the RSU. And these devices work together to gather and share real-time information. Sensors and the cameras monitor the vehicle and its surroundings. GPS provides the location information, and RSUs help vehicles communicate with the transportation infrastructure. Now here it highlights the functions of the this image. It highlights the functions of the device layer. That is, it includes the collecting of the data, monitoring the vehicle, then monitoring the environment and sharing the information with other layers of the vehicular system. And all the information collected by this layer, it is sent to the higher layers for further processing and the decision making. Now here you can see there are three types of data collected. So here the first is the internal environmental sensing, which refers to the information gathered from inside the vehicle. For example, engine temperature, then fuel level, battery status, tire pressure, vehicle speed. And this information helps to monitor the health and performance of the vehicle. Then comes the external environment sensing, which refers to the information collected from outside the world. It includes the traffic conditions, road obstacles, weather conditions, nearby vehicles, and the pedestrians. And here it helps the vehicle to understand its surroundings and improve the safety. Now, third is the event triggering. When an important event occurs, the system automatically generates alerts. For example, it includes the accident detection, driver fatigue detection, vehicle entry into the restricted areas, and the sudden braking. You can see a real-time example, real-life example here. A car, it detects a pedestrian who is crossing the road using the sensors. Using its sensors, that is, the car is having sensors, and it will detect the person or the pedestrian who is walking here or who is crossing the road. Now the collected information is immediately sent to the upper layers for processing, allowing the system to respond quickly. And the device layer is the foundation of the vehicular IoT. It enables the real-time sensing, monitoring, and communication for safer and smarter transportation. Then comes the fog layer, which is the middle layer between the devices and the cloud, and it processes the data close to the vehicles. So the main purpose of the fog layer is to process the data close to the vehicle so that important decisions can be made quickly without waiting for the cloud processing. So here you can see connecting fog layer is shown connecting the vehicles or the devices to the cloud. Here you have vehicles, then here you have a fog layer which is connecting to the cloud. So instead of sending all the data directly to the cloud, the fog layer processes the critical information near the vehicles, and this reduces the communication delays and it improves the response time. That is, it will not directly send the data is not sent directly from the vehicles to the cloud. First it is sent to the fog layer, then the critical data is sent to the cloud layer, to the cloud. So this reduces the communication delays and it improves the response time. Now here, why fog layer is needed? What is the reason? In transportation system, the decisions often need to be taken within milliseconds. So if all the collected data is just sent directly to the cloud, then the network delays may occur, and during emergencies such delays can be dangerous, and because accident may happen before a response is received. Therefore, fog computing performs the data processing close to the vehicles, enabling immediate action whenever it is required. Here you can see a fog node. It receives the different types of information such as the traffic data, then sensor data, camera data, vehicle status, location data, and some other vehicle status information. So the fog layer or the fog node, here the fog node, it analyzes this information and it makes quick decisions. Since the processing happens locally, responses are much faster than the cloud-based processes. processing. So here you can see some important functions of the fog layer, that are the low-end processing, small-scale analytics, short-term data storage, and the real-time decision making. These functions help the system react quickly to changing road conditions and the traffic situations. And here you can see the advantages of the fog layer, that is the faster response time, reduced latency, then reduced network traffic, better traffic management. Because only important data is sent to the cloud, network congestion is reduced and communication becomes more efficient. Now here you can see a practical example. A vehicle suddenly applies the brakes. Then the nearby fog node immediately detects the event and it sends the warning message to the surrounding vehicles. And this warning is delivered without waiting for cloud processing. And as a result, nearby drivers receive alerts quickly and cars slow down or stop in the time. So the fog layer, it plays a vital role in the vehicle IoT by processing data near the vehicles, and it provides a real-time decisions which will help to create a transportation system that is faster, safer, smarter and more reliable, while significantly reducing the chances of accidents and improving the overall traffic management. Now next comes the third layer, which is the cloud layer. Here this is the topmost layer of the vehicular IoT architecture, and it is the most powerful layer because it contains high performance servers, large databases and huge storage capacity. Okay, here. And the cloud layer, it receives the data from the fog layer. Okay, and it stores, processes and analyzes the information collected from thousands of vehicles. Now here you can see a cloud server and a database. These represent the cloud infrastructure that stores and manages large amount of information. Unlike the device layer and the fog layer, which focus on local and real-time operations, the cloud layer, it handles large-scale processing and long-term data management. Now you have some functions of the cloud layer, that is high-end processing. It performs complex like computations on the large data sets. Then big data analytics, analyzing huge amount of information collected from the vehicles. Then comes the long-term storage, where storing data for months or years. Then comes the decision support, that is providing useful insights and recommendations for transportation planning and management. Now here you can see the different types of data stored in the cloud, that is the vehicle routes, then you have camera footage, accident records, fuel consumption data, maintenance reports and the traffic history. All this information is collected from the vehicles through the device layer and the fog layer and then stored securely in the cloud databases. Now another important section is the advantages of the cloud layer. Here first is the large storage capacity, which allows huge amount of data to be stored. Then comes the global accessibility, which enables the users to access the information from anywhere in the world. Then you have the advanced analysis, which helps identify trends and the patterns. And the last is scalable resources, which will allow storage and processing power to increase as the number of vehicles grows. So you can see a practical example here, where the traffic data from the thousands of vehicles is collected and sent to the cloud, and the cloud then analyzes this information to identify the traffic patterns, accident prone areas and the road usage statistics. Using these analysis, the city authorities can understand how the roads are being used and where improvements are needed. So this helps in planning new roads, then improving the traffic signals and reducing the congestion and also enhancing the road safety. So you can see there is a connection between the device layer, fog layer and the cloud layer. Here device layer, fog layer and the cloud layer. So the data flows upward from the vehicles and the sensors to the fog nodes and then finally to the cloud. So the cloud then generates the valuable insights and supports decision making. So the cloud layer, it is like the brain of the vehicular IoT, system, and it stores and analyzes massive amounts of vehicle data and also provides advanced insights, supports transportation planning, and helps create a smarter, faster, safer, and more efficient transportation system. So this was about the introduction and architecture of vehicular IoT. Thank you.